Assalamualaikum warahmatullahi wabarakatuh. My name is Rizky Satrio Putra Sunjaya. I'm from Trisakti University Petroleum Engineering major, and today I'm going to present my presentation about hydraulic fracturing, titled Tunnel Hydraulic Fracturing Evaluation and comparing with conventional hydraulic fracturing computation. Basically, I'm going to differentiate between the tunnel hydraulic fracturing method and the conventional hydraulic fracturing method. So, for the introduction, hydraulic fracturing is one of the stimulation jobs that performed by injecting high-grade fracturing fluid to the formation through the wellbore in purpose to create a conductivity by exceeding the fracture pressure in formation. Tunnel hydraulic fracturing uses a different method from the conventional hydraulic fracturing. The most dominant difference is at the pumping technique. The chosen of candidate well depends on the rock characteristic, reserves, and the potential for the rock characteristics such as Young's modulus and Poisson ratio, and reservoir reserves needs to be high enough to get produced from the well. And the chosen well has never been put up on production until it's fractured. Only flow tested on open choke shows good trace of oil, accumulated 44.3 barrels of 95% until 100% of oil. The well permeability is around 8 md with a reservoir pressure of 1824 psi based on lock and horn. Then, for the methods that are being used, actually is the common rule of thumb from hydraulic fracturing. The well needs to be selected based on rock stresses and plane strain modulus to gain the value of candidate selectivity factor. Other than less minimum or more maximum the value of the candidate selectivity factor, the formation is either too fragile or too tight. Hydraulic fracturing job itself divided by several jobs, which are breakdown tests or injectivity tests, step retest, step up and step down, and mini frac. And for the main job itself, we call it the main frac. Propan selection for this job depends on closure pressure we encountered in last test, which is mini frac, perforation diameter, and also from the design on how effective conductivity we need to maximize the well. The most significant difference from the conventional and the tunnel method is the pumping technique and frac fluid additives that I have mentioned in previous slide. Let's dig the results and discussion. This well is chosen because of the value of rock stresses and plane strain modulus show a viable candidate for the job, which means the value of the candidate selectivity factor is in between the minimum value and the maximum value. The productivity index, or PI, based on the method used, model geometry, and the actual operation is 4.2 times from the assumed production of this well. In the actual operation on the main frac, pumping charts show there are 13 stages from the initial frac fluid until the Aasec. These 13 stages consist of slug injection, frac fluid injection, and the changing concentration of propant, and the shut-in pump, and the initial shut-in pressure. From fracture geometry, the total fracture value is 543 cubic feet based on fracture half length, height fracture, and the width average. And last, for the conclusion, the geometry created from channel or tunnel fracturing method is 120% bigger than the conventional method. Reduce the risk for screen out due to propane usage for the channel fracturing is less than conventional fracturing. The actual initial production is expected same as forecast and proven from the flow test. The artificial conductivity from pulsation pumping technique, the conductivity from channel fracturing is higher than conventional fracturing. And for the acknowledgement, we would like to express gratitude to Teknik Perminyakan Fakultas Kebumian dan Energi, Universitas Trisakti, for all support given in presenting this paper in the 2020 AACAC. Thank you for the opportunity. Waalaikumsalam warahmatullahi wabarakatuh.